Hi there, this is video 628. We are almost done in chapter 6. Good job. And we are looking at the first of, I think it's 2 optimization problems we're going to do together. Okay, remember optimization is looking at the maximum and minimum of some value. So let's take a look. I've got our steps here. So what do we need to do? Figure out what we're optimizing. So that's what we're maximizing and minimizing. Define our variables, write your inequalities graph, objective function. Objective function is got to do with, basically it describes what you're optimizing. Determine the values of the objective function. That's when you find the corners and substitute values in and see how that goes. And then, is my answer reasonable? So keep those things in mind while we go through the question. 3 teams are traveling to a basketball tournament in cars and minivans. Each team has no more than 2 coaches and 14 athletes. Each car can take 4 team members and each minivan can take 6 team members. No more than 4 minivans and 12 cars are available. The school wants to know the combination of cars and minivans that will require the minimum and maximum amount of vehicles. Create a model to represent this situation. Okay, so here's where we start. Wherever you see we want to minimize and maximize, that is what you are optimizing. So we're optimizing number of vehicles. All right. So then it says define our variables and constraints. And what do we care about? Well, we're caring about the vehicles. What kind do we got? We have some minivans. We got some cars. So C is equal number of cars. And let's see, no more than 12. And it's gonna be, while we're at it, C is an element of, it doesn't say we have to take a car or a minivan. There's nothing saying we have to take at least one of each. So we're gonna use whole numbers because 0 is okay. So we go M is number of minivans. Where does it say? No more than 4. And minivans is an element of W. Okay. Now, what about these? Well, what else are we going to figure out here? Number of people. Each team has no more than 2 coaches and 14 athletes. So we got 3 teams times 2 coaches and 14, that's 16. We got 48 people that we have to take on this trip. That's a fair amount. Now, how does this connect to that? Well, let's see. It's kind of like those price questions, except instead of, it's $4 for some cookies or something, it's how many people. So each car can take 4 team members. So 4 people per car plus 6 people per minivan has to be less than or equal to 48. So that's our big main equation. But this part gives us something. So cars is less than or equal to 12. And minivan is less than or equal to 4. So there we have our 3 variables. And you know what? I'm going to make C is the same as X, and this is the same as Y. We got our variables, we got constraints. We need to write our inequalities, which we just did. Now we need to graph. So I'm going to start with this one. It's kind of the most complicated. It's also going to give us an idea of what kind of values we need to do. So x, 4x plus 6y is 48. Right, so I took this and I just switched the c and m to an x and a y. 0, 4 times 0 plus 6y, 48. 0 plus 6y is 48. Divided by 6, divided by 6. Y is equal to 8. Now, because 48 is a fairly big number, and I'm going to try 4. So 4 times 4 plus 6y is 48. 16 plus 6y is 48 minus 16 minus 16. I don't know today what minus 16 is. 32 maybe? 48 minus 16. Ooh, 32. 6y is 32. And divide by 6, 5.3. Yeah. Whoops. Sorry. What else should we try? Try 6. So 4 times 6 plus 6y is 48. 24 plus 6y is 48. Minus 24 minus 24. 6y is equal to 48. No, it's not. 6y is equal to 24. Otherwise, yeah, we subtracted. Divide by 6, divide by 6. Y is equal to 4. All right. So we're going to graph this. And I'm not particularly fond of this graph paper, but that's okay. We'll use it. And I'm going to make my axes kind of off center because we know it's going to be whole numbers. So all the interesting stuff is happening in the first quadrant. I don't think we went higher than 8. So when x is 0, y is 8. Over there. When it's 4, we're at 5.3. There's 5 there. Well, it's about there. And at 6, it's equal to 4. All right. Now, all of the inequalities that we set up, excuse me, are have the equal to part. So I can draw a solid line. And I'm just going to write 4x plus 6y is less than or equal to 48. I'm going to outlive this is number 1. So now we need to do our checkpoints. I have a feeling I'm going to run out of room on this page. That's okay. So do my usual. Whoops. Start with the equation again. 4x plus 6y is less than or equal to 48. So 4 times 0 plus 6 times 0 is less than or equal to 48. So 0 is less than or equal to 48. So this side is good. And let's go 8 and 8. 4 times 8 plus 6 times 8 is less than or equal to 48. I already know it's not. It's 32 plus 48. But I want to do the question anyway. All right. So for this line, it is, we're talking about the number of cars and stuff. So it's going to be whole numbers. I'm sorry. Okay, that's fun and all, but that's not that. All right. So there's our main one. That's equation number 1. Let's do the most complicated one first. Now we've got, let's see, we said c is equal to x, so x is less than or equal to 12. Whoops. So better keep going. 9, 10, 11, 12. So this is going to cross the x-axis at 12. All right, well, we need to do checkpoints, although it's not really very challenging. Let's do 0, 0. I'm just going to put a, although that doesn't, it shows up a little bit. So x is less than 12. 0 is less than or equal to 12. So this side looks okay. If we try a different checkpoint, I'm getting squishy here. We need to be on the other side of the line. So let's pick that one. 14 and 0. X is less than 12. 14 is less than or equal to 12. No. Yes. So no. So for the green line, weirdly doesn't help very well for you guys. It's going to be, I'm doing it again. Oops, not that one. Etc. So green dots, and it would actually go all the way up and all the way across. So we can see right now that this part is looking like it's going to be interesting, right? Because this section below the line and over here, so right now this triangle is the beginning of our feasible region. have one more equation left to deal with, which is this one. And that's going to be, so my m is the same as y. So y is less than or equal to 4. So I need to find my y-axis, and I need to find 4, which is right there. And that's where our line's going to go. Y is less than or equal to 4. Oh, why did I put the 4 there? Sorry. All right, so checkpoints. You guys already know how this is going to work. 0 and 0. Y is less than or equal to 4. 0 is less than or equal to 4. So this side looks yes. And if we pick a spot on top of that, I don't know. Use 8 and 8 again. Y is less than or equal to 4. 8 is less than or equal to 4. No. So this side, no. So now we're going to go below the line and include, oopsies, not there. I'm over, should be over 1.
Hi, Murray. Hi, how are you doing? I'm doing good.
Okay, so.
The window guys are going to be coming in and doing some of the doors on the second floor today. Yeah. And it's okay, but I thought that's appointment at 12:30, so I have to leave here about 12 or shortly after. So and Dave's away, so I'm heading to.
That is our feasible region. So all of our answers should be in that area. Okay. Now, the only thing left, and I'm really running out of paper, and I'm just going to pause the video for a sec. All right. Awesome. I don't know, something glitchy, and my husband just helped me, so thank you, dear. You're awesome. This way we can finish the video and not have to make it part 2. Okay, so we really seriously did run out of room. So I'm going to move my page up. And we have to figure out the maximum and minimum. I guess I'll move back down. All right, so we got to, our graph is done. Now we need to write our objective function. So this is step 5. And, oh, hold on. I better put my paper this way, simply because this is just going to end up with our answer, my answer set. So this is U628, part 2. So I was saying, we are at step 5, which is write the objective function. So we got to go back. And what were we trying to optimize? Well, we were trying to optimize. The school wanted to know the maximum and minimum number of vehicles that we're going to take. So vehicles, well, what is it? It's going to be X plus Y, which remember X stands for cars and Y stands for minivans. Okay, so that's number 5. And then it says determine the values of the objective function. And the trick is to figure out the value at every corner. Keep it up so you can see. All right, so we need the coordinates of our corners. So we've got 0 and 0. We have 12 and 0. We've got, where is that? 6 and 4. And we've got 4, 0 and 4, sorry. So these are corners, and that's where the maximum and minimums are going to occur. So now we just take and use this formula. So B is equal to X plus Y. B is equal to 0. I'm thinking that's going to be our minimum cost. So I guess if we take no cars and no minivans, that is the minimum amount we can take. Fee is equal to 12 plus, oopsie. Okay, it's X plus Y, but do it right. Oops. Got all stressed up there. It's equal to 12. B is equal to 6 plus 4. I forgot my formula, but it's okay. B is equal to 10. And B is equal to X plus Y. B is equal to 0, oops, yep, plus 4. All right. So the least number of vehicles we can take is 0. That makes complete sense, right? That's it. The most, okay, so if we want to look at this, the most number of vehicles we're going to take is going to be 12. And that's basically when we took 12 cars, right? That makes sense. The most we're going to take is 12 cars. And this is where this is kind of like the part 7. Is it reasonable? Well, if we want to take 48 kids and each car can take 4, 12 cars is going to make it happen. And this one is 6 cars and 4 minivans. And this one refers to just taking the 4 minivans. And there we go. That's the end of the question.